Okay, so just to recap, so far we've talked about a system of equations being a set of two or more equations with the same unknowns. And then we talked about, based on what form the two equations are given, two or more equations are given to you in, which method is most appropriate or easiest to use to solve. Okay, we said we have three methods. We have graphing, we have substitution, and we have elimination. You should have seen graphing and substitution in 8th grade. We'll do those again. And then elimination's a little different, a little new. And we'll spend a good bit of time on that. Okay, so first looking at how many solutions we have. Looking here, I have two equations that are graphed. So I have a system of equations that is graphed. And where they cross, where they intersect, is their solution. So their solution is right here. So they only cross at one place. So they have one unique solution. And the solution is at that intersection. So make sure you write it as an ordered pair. Remember, it's x comma y, 3, 0. Now, thinking about that, these two lines, they cross down here, but then they cross up here, they cross here, they cross here, they cross here, they cross here. They cross everywhere up and down these lines. Okay, and lines go on forever. So it has infinite solutions. Every single ordered pair on this line is a solution. So we're going to write infinitely many solutions. Okay? So to have infinitely many solutions, the two equations really have to be of the same line. Notice they're laying on top of each other. They cross everywhere. The other option that we have is that we have two lines with the same slope. Notice this slope is -1/2 and this slope is -1/2. Okay? If it has the same slope, that means it's rising and running. The change in y and the change in x are the same for both of them. So it's going up or down and over at the same rate. Okay? If that happens, that means you have parallel lines. Parallel lines we know never cross. Okay, they're going to go on and on and on forever. They're never going to cross. So if there's no point of intersection, then there's no solution. Okay? That's only going to happen if the slopes are the same. If the slopes are not the same, then eventually they're going to cross. We may just have to extend our lines out further to see where they cross. Or use another method, but we'll talk about that later. Okay. So once again, crosses in one place, it has one unique solution. Same line crosses everywhere, it has infinitely many solutions. And parallel lines never cross, so they have no solution. Okay, now let's look how we actually come up with that graph so that we can decide if it has one unique solution, infinitely many solutions, or no solution. So we're going to solve the following systems by graphing. And I just want to look at this one equation at a time. So I'm going to start right here with this top equation. This top equation is y equals 1/2 x minus 3. This is solved for y. It is in slope-intercept form, so we are ready to graph it. So we're going to start at our y-intercept at -3. We're going to go down 1, 2, 3, and put a point, and then our slope is 1/2. So we're going to rise 1, run 2. Rise 1, run 2. Okay? Remember, change in y over change in x, rise over run. So this is up, this is over. Remember, you read left to right, so go left to right. Okay. See if I can, there we go. So there's our first line. We connected the points, put arrows on the ends because lines go on forever. There's our first line. So now let's look at the second line. Second line starts at 1, has a y-intercept of 1. Here's my y-axis, so here's 1. And then it has a slope of negative 3 over 2. So the negative tells me I'm going to go down. So I'm going to go down 1, 2, 3, right 2. Down 3, right 2. Okay, which gives me this line right here. And then we connect our dots. Put our arrows on the end. Okay. And we can see that these two lines cross right here. So our solution is where they intersect, where they cross, which is right here at 2, negative 2. Okay, remember it's x, then y. All right, looking at the next one. This top equation we're used to graphing. So we're going to start at negative 3. And then we have negative 2 for a slope. Remember that we can put all whole numbers over 1. So we're going to go down 2 over 1. And if you want another point, you have to think about where it would be that you would go down 2, right 1. So it's the same as going up 2, back 1. Notice that's still on that line because this would be down 2 over 1, down 2 over 1. So if you need another point, you can always change both directions. Okay. And we did that when we graphed lines. So then, we're going to draw our line through I don't want it blue. But we'll draw our line through those 3 points. All right, now looking at the second one, remember that this is a special situation. This is a special line. So remember, if it's x equals negative 3, we go to where x is negative 3. And remember that x is negative 3 all the way along this line. Okay, so we just have a vertical line through negative 3. Okay. Then our point of intersection is right here at negative 3, 2. So our solution is negative 3, 2. All right, let's look at one more. So here, this one is almost solve for y. So sometimes graphing is still the best option if it's almost to where they're both solved for y. Okay, every once in a while they'll leave just like a coefficient or something that you have to move, or just an x that you can add or subtract over. Okay. So this one's good to go. This one's solved for y. I know how to graph this. This one's not quite there yet. So let's start with that. We have negative 3y equals x minus 6. Write this on your paper as well. We can divide both for all 3 pieces by negative 3. Take that y by itself. We've done this before. Solve for y. Get it in function form. We have y equals, remember, if there's not a number right in front of that x, the coefficient is a 1. So we have negative 1/3 x, negative divided by negative is a positive, 6 divided by 3 is 2. Okay. So then I'm going to graph this. I'm going to start at positive 2. And then the slope is negative 1/3, which means I go down 1 over 3. And the next one will be off my graph, but it would be about right here. And I'm going to draw that line. Okay. All right, the second line, already solved for y, so my y-intercept I can see right here is negative 1. And then it's going to go down 1 over 3. Okay, and hopefully we're starting to see, or maybe we already noticed, that this was kind of a special situation. Okay, these have no intersection. They don't cross. And I can verify they don't cross looking up here, because here my slope is negative 1/3, and here my slope is negative 1/3. So we have no solution. If they never cross, if they're parallel, then there's no solution. Okay, and I'm going to leave this last one for you. Try this on your own, and we will check it together. And that is solving by graphing. Let me know if you have any questions.